Hi everybody, welcome to lesson 1 in which we're going to start graphing quadratic functions. So we've been playing around with quadratic equations that deal with x squared polynomials. So in this whole unit, for the most part, we're going to be looking at how we graph these quadratics that we've been solving. So below here, I have two graphs of quadratic functions. Complete the table for each graph. So here is our first quadratic function we're going to look at. It's called a parabola. So this U-shaped curve here is called a parabola, a parabola. It's a parabola, and it's from the graph of x squared functions. This is a graph that has to do with x squared. So it's got arrows going up on both ends because it skyrockets up forever. And I want you to just pick out points in this table. So I gave you the point -1, 8. Well, here's another nice point, 0 up 3. There's another nice point, 1, 0. That point was already given to me. This is the point 3, 0, right? Over 3, don't go up or down anything. 4, 3, and then looks like it's 5, 8. So what I want you to notice is that, wait a minute, isn't there symmetry in this graph here? Isn't there that symmetrical part of this table here? Where look, everybody kind of has a matching partner. And here, this 2, -1 kind of represents that turning point of the graph there, because he doesn't match up with anybody, but everyone else has a partner that's on the other side of the graph. So see if you can do that for this one here. Pause the video and plot me some nice points and see if this parabola also has that symmetric nature. So hopefully you're back and hopefully that went well. And here are the points I found. I found the point -5, -5, -4, 0. That point's there, that point's there. -1, 3, 0, 0, and 1, -5. So hopefully you noticed that this parabola also has that symmetric nature in the table, where we can find that turning point by looking at our table and looking in the middle. So these two equations have what's called an axis of symmetry. Every parabola has an axis of symmetry, and it's kind of like the mirror image line. So I just drew in the axis of symmetry there. If I flip over that line, if I was to fold this piece of paper on top of itself, it would land on itself and match up perfectly. So the axis of symmetry is always x equals, because it's a vertical line. And in this point, what does x equal? Where do I hit the x-axis? X equals 2. At x equals 2, that's my axis of symmetry. And look right here. What's the x value of that middleman? 2. Here, if I draw on the axis of symmetry, where's the middleman? X equals -2. X equals -2 is the axis of symmetry here. And there it is. There it is in my middleman there. -2 is the value that cuts that graph right in half. It splits it right down the middle. So that's an important vocab word we're going to be looking with these parabolas. Parabolas are all about symmetry. It's all about that repeated. If I flip to the other side, it's exactly the same thing. We can see that on the graph, and we can also see it in the table. So using the graph here, let's talk about these parabolas. The x-intercepts have a couple names. They're called the zeros or the roots of the parabola. They have special names. The x-intercept is where I hit the x-axis. And these are so important. The zeros, the x-intercepts, these are so important. We basically spend this whole unit talking about them. So the x-intercepts are where I hit the x-axis. 1, 0, and 3, 0. These points right here are my x-intercepts. 1, 0. When do I equal 0? These are my x-intercepts right there. 1, 0, 3, 0. If I go to the g of x graph, the second one, where do I hit the x-axis? -4, 0. When do I equal 0? That's why we call them my zeros, because it's when do I equal 0? I equal 0 at 0, 0. So those are my zeros, my x-intercepts, my roots. Those are the points where I cross the x-axis. That's a huge idea. The vertex, I'm going to say a lot, that's the turning point. The vertex is the turning point of the parabola. So that's that middleman. That middleman is the vertex there. What's that? Where does the parabola start to turn around? In this case, it's 2, -1. And for g of x, where does it turn around? -2, 4. This lesson's all about vocab of these parabolas because they have a lot of vocabulary. So is this vertex a maximum or a minimum? This point here, is this a maximum of this curve or a minimum? Is that the highest point or the lowest point? Definitely looks like the lowest point. Whereas the other one, that looks like it's the top of the hill, right? That vertex there, -2, 4, that middleman, that's the highest y value in my table there. So that's a maximum. So the vertex is always the maximum or the minimum. So I've got two new vocab words here called concave up or concave down. And if I was in class, I'd be having my hands going up and down, but you can't see that. So concave up parabolas go up to infinity for forever. Concave up makes a U shape. They make a smiley face. Concave up smiles, whereas concave down opens downward. So concavity, concave up or concave down, kind of tells me where my arrow's going. Are both my hands going up or both my hands going down? Am I concave up or concave down? So the first one is that U shape. The arrows are going up, so that's concave up. Whereas the second one is opening downwards, it's concave down. So this is concave up because it's making that U shape, whereas this one's concave down because it's making that frowny face shape. So we're going to move on for the vocab there. I don't want to get too crazy. I want to make sure that we get the basics of a parabola. The zeros are important. The roots, the zeros. The vertex is important because it also helps us find the axis of symmetry. Where's the axis of symmetry? It's the x value of the vertex. So that vertex is important. These are the vocab words that we're going to play with for this entire unit working with parabolas. The zeros, the x-intercepts, those where do I hit the x-axis, and the vertex. So below you only see one side of a parabola. Pause the video and finish this parabola for me. Plot me 3 more points. So pause the video and try that for me. Did you pause it? I hope you did because I'm going on here. So this is my turning point right here. So I've got to reflect it over that axis of symmetry. There's the mirror image. I'm going to flip it over to get those new points. I'm going to perform that reflection that you guys learned about last year to make the second half of this parabola. And there it is right there. Beautiful. Arrows going on, plummeting down forever. So let's make the table. -3, -5. We always go left to right. -2, 0. I'm just picking the points off the curve. -1, 3, 0, 4. And now it should start repeating. 1, 3, 2, 0, and 3, -5. Notice there's that symmetry in this table. There's that symmetry there. What are my x-intercepts? What are my zeros? Where do I hit the x-axis? At 2, 0 and -2, 0. Who is the vertex? Well, the vertex is this turning point here, the middleman. The highest point or the lowest point on the graph is 0, 4. That's my vertex. And the axis of symmetry comes from that vertex. X equals 0. That vertical line, x equals 0, comes right from the vertex, is my axis of symmetry. So parabolas aren't that bad. They have these big ideas that are going to be important as we go on. But once you get these down and into your head, parabolas and quadratic functions are pretty easy to work with. So graph this function on the set of axes below. So what I need you guys to realize is, wait a minute, this is an x squared graph. X squared graphs make parabolas. They should have that parabolic shape when I graph it. So how do I graph something? I go to my calculator. I go to my calculator and I type in y equals in this upper corner here. Y equals x squared minus 4x minus 5. That's the graph I need to make. So I hit graph, and I should see, oh, look at that beautiful parabola right there. And I'm not just going to draw that. Remember, we can go to our table to get the points. We're going to go to our second graph to get to our table. And I said parabolas were all about symmetry. So we're going to look in this table, look in the y values for symmetry. You want everyone to have a partner. You want everyone to have a matchy-matchy. Everyone's got to match up with someone. So look at this, 16, 16, 7, 7, 0, 0, negative 5, negative 5. I found that symmetry. So what I'm going to do is I'm going to, hopefully, I don't want Google. Hopefully I'm going to steal this table. Let's see if I can do this here properly. I'm going to steal that table and drag it into OneNote here. Let's see if I did it right. Oh, I did it right. So there's my table. There we go. I'm going to plot these points. Now this grid is only 10 by 10, so I'm going to get rid of that. Everything else I'm going to plot. Negative 2, comma 7. Negative 2, up 7. Negative 1, comma 0. 0, negative 5. 1, 2, 3, 4, 5. 1, comma negative 8. So when we graph anything in math, just go to your calculator and get the points. Get the points that you're going to use to graph. 4, negative 5. 5, comma 0. 6, comma 7. And notice it should have that symmetry. It should have that symmetry on both sides where it has that mirror image, that parabolic shape, that mirror image where everyone matches up with someone else, just like we see in our table, 7, 7, 0, 0. State the x-intercepts. So I can get those from the table. Where do I equal 0? Or I could actually look at the graph. What are my zeros? Negative 1, 0, and 5, comma 0. Those are my x-intercepts. The zeros, the roots, those all mean the same thing. Who's the vertex? Well, the vertex is my middleman, that turning point here. 2, comma negative 9. State the equation of the axis of symmetry. Well, that comes right from the vertex. The vertex tells me the axis of symmetry is x equals 2. The x equals 2. A vertical line goes through 2. Is this concave up or is this a concave down parabola? We're going to skip increasing and decreasing. Is this a concave up or a concave down parabola? Well, it opens upwards, so it's concave up. It's a concave up parabola. So when we graph things on our calculator, all we have to do is go to y equals. And I need you to realize if I'm graphing x squared functions, it should be making a parabola. Don't actually just sketch the parabola. Hit second table to actually look at the table and find the symmetry. Find the matchy-matchy in your y column there to plot those points. And then plot the points you can. You can't plot 7, 16 and negative 3, 16. But there's a bunch of other points you can plot to make this beautiful parabola here. So hopefully you feel good with this vocab. Zeros, vertex, and the axis of symmetry. And we can use our table and our graphs to find these values. See you guys in the next video.